And we are live. We are on air. We are ready once again to put up an amazing show, an amazing coding show, some late night coding. Well, actually, it's not so late at night, but still, a lot of people are watching Netflix. A lot of people are playing Call of Duty, World of Warcraft, League of Legends, but we don't do that shit. We don't do that stuff because we are the army of the high value engineers. And the only thing we do is absorb information so we will know more than everybody else. That's what we do. And let me first notify the whole world that I'm live. Wait a minute. So Twitter, of course. I just tweet because I already prepared everything I need. And of course my Discord, boom, it's already been done. Already been taken care of. How is everybody doing? What is poppin'? How is your day? Or maybe your day still needs to begin. I have no clue. All right, so this stream, this morning actually, let me open up this window a little bit bigger, right, so I can demonstrate. This morning, actually yesterday, the whole story started yesterday where we are creating a blockchain from scratch, right? And we have a lot of stuff already. But I wanted to implement the way of syncing so that our blocks can sync, especially nodes that are booted up late to the network. So they are basically they are behind in height. So we need to sync them. There needs to be a way to sync them. And I was implementing this yesterday 2 times in the stream, yesterday's streams in the morning and yesterday's streams in the evening. And we had some issues with our transport implementation, which is a Golang interface. And we had a local transport, and it was a lot of shenanigans was going on. I'm not gonna lie, it was a perfect implementation until yesterday. So I decided this morning to rewrite the whole protocol, the whole transport layer into TCP. That's what we did, and we are going to continue that. As a matter of fact, we are going to sync our network. That's what we're gonna do, and we won't stop. We don't stop until it's done. That's what we're gonna do, and I have all precautions about my camera because yesterday's stream, it was overheated. I don't know why, because I think we were on fire. That's the reason why it was overheated. But I did some tricks of the sleeve that it will happen. So enough shenanigans, enough bullshit. We're gonna start. Let me quickly check if the stream health is okay, because with YouTube, you never know. It's okay. It's time. It's time, boys and girls, and everything in between. All right, so let's basically, what we're gonna do is make run to see what is going on. So we have 3 nodes that we boot up in TCP, 3 nodes with their own address. And they connect to each other. It's all good. We have a validator that produces blocks, and we broadcast the blocks to all the nodes so they are in sync. But when we boot up a new node, he's going to stay behind, right? And that's what we're gonna fix. Yeah. Okay, so the first thing, let me quickly check. There are a couple things we need to do because add Mutex, please. Right, that's important because we have a map, this peer map, and we need to have a mutex. I'm gonna call this MU. It's gonna be a sync RW mutex, which basically means protection for read and write. That's what we're gonna do. And actually, if you wanna be a good Go engineer, what you should do is basically do it like this. So we know that this mutex is protecting the peer map. All right. Where is this peer? And my back is starting to hurt because I'm sitting at the most scuffed seat you will ever find. But it's all worth. It's all worth. So what we're gonna do is this peer map, right? Add mutex. So we're gonna say SMU, and this is going to be a write lock, right? So we're gonna say add a lock like this. And actually what you could do is here, we should not, don't use a defer. We're going to say add unlock. Yeah, like this. That's good. Do we need that somewhere else? Yes, in Bootstrap network. Where is this? Bootstrap. Here. We are reading. Are we reading? And by the way, I don't think we need this mutex, by the way, because this channel is an uncapped channel. It's a capped channel, by the way. So that means that we can, if we want to insert peers, it will always happen in sync by the channel. Where are we reading then? I think it's in broadcast, by the way, in broadcast. Where is that? This one. This is going to be addlock. I was wrong. Addlock is for reading, right? Like this, that should work perfectly fine. And I'm going to delete this lock from the peer shenanigans we did in this loop. Here, I'm going to delete this. Not quite sure this is going to work. Let's see. Could be that we are in a lock, but I don't think so. And to be honest, it really doesn't actually... I mean, peers, it doesn't change that much, right? It doesn't change that much. So it doesn't really matter. But still a good practice. So, what we gotta do is, once we connect with another node, once we add a peer to the peer list, we are going to send a get status message to that peer, which basically means that if there is a peer connecting to us, we're going to say, hey, yo, peer, hey, yo, other node, remote node, give me your status. And what I mean by that is, give me the highest block. Give me your height. What is your height? What is your status? How it's going? Who are you? That's what we want to know, because if his height is higher than ours, it means that it's a very interesting node, because we are going to request blocks from him so we can sync. So we can sync until his height. That's the reason. And if his height is equal or lower, we are not going to ask for blocks, because we are in a better state or in the same state, right? That's how blockchains work. That's how the syncing works, the gossip protocol works. And of course, we did this yesterday, but due to shenanigans, we couldn't actually make this work. So send get status message. Gop and code as get status message. Okay, this transport, that's the thing. So we changed this, right? We changed this. Send get status. What we want is basically a peer. We want a peer, which is a pointer to a TCP peer, like this. And we're going to say, instead of the shenanigans, we're going to say, if error is peer sent, error is not null, we're going to return the actually. Actually, you could do this, right? Could you just do this and delete all that garbage? Message, and it's going to be the bytes of the message. Yeah, I think that to do remove logic from the main function to here normally. It's all been done, man. Don't worry about it. Don't worry about it. So send get status message, we take in a peer. So where do we send this message, right? I think we could do it inside of Bootstrap network, right? Or in here. So we could say if r is going to be s send get status message. So we could do a little, let's make the comment after, right? So we know what's going on. We're gonna say it's the peer, and if the error is not null, we go into s logger log. What is going on? We're gonna say r, and it's gonna be this guy, right? We're gonna continue, I think, not sure, because otherwise we'd say new peer. Do we care? Do we care? That's the question. Do we care? Because the peer is in our map anyway, so we have the peer in our server, even though send get status message is not going to be fulfilled. We will see, we will see. Sometimes you don't know things up front. Okay, so that should work, right? So now we need to make sure that we can handle that message. If we receive a get status message, I think we did this process status message. No, that's already a step too far. Process get status message. That's what we need. So we print this receive get status, but we're gonna remove this because we're gonna say as a logger log message received get status message from, yes, like this is good, and then we can say from. And the reason why I'm using the logger is because we had a prefix to it, so we always know what node is sending what, right? It's important for debugging. This is wrong, this net adder, we refactored this. I think we could do a net address, right? The native Golang standard library tools. And we're gonna say it's from the net adder, right? For some reason. Oh, delete here and then from here, all right. So this is this byte buffer, we decoding the message. So basically what we do is we make a status message. We give our the height, or blockchain height. We put it in that message. We give our ID and call it a day. And this we need to refactor. This is the same thing. It's basically, damn, we are in trouble. We are in a little trouble. Wait, so where are we calling this? GD? Nowhere. Why are we in trouble? Because we need to fetch the peer from the map, which is actually no big of a deal. But process get map, that's basically when we RPC. Aha, here. Yeah, the project, it's a big project, right? I'm building this for a long time. So there's a lot of files already. So it's getting, you know how big projects are, right? It's getting, we need to make our hands dirty to find things. Get status message. So this basically says we process a message, right? So if we get a message, we're gonna decode the message. We're gonna type, switch on the type, right? And then we're gonna say, we're gonna distribute, we're gonna route based on that message. Status message, that's the next step. Okay, it's a from, yeah, well, all good, hey. It's all good, buddy, no worries. No worries, we're gonna say, and actually, that's why we need this mutex, I think. We're gonna say SMU. It's a read lock for reading. Defer SMU R unlock, right? Like this, and then we're gonna say, actually, peer is going to be as peer map rather, and we're going to put in this from, right? Grab the peer, make the message, and then we're going to say actually peer send message bytes, right? And call it a day. Sometimes it's easy and sometimes it's not, right? Okay, so now I think if we boot up, if we make run, it should actually do some good stuff. Let's go. New peer, okay. Okay, received get status message, all good. Executing code, that's our VM. We also have a little VM that we built, and it's actually executing bytecode. It's executing our own smart contracts. Isn't that amazing? But I need to make sure. Wait, I'm gonna stop this so we can actually debug a little bit, and we're gonna remove all these unnecessary loggings, because this is the contract state. Because our smart contracts is a very small piece of bytecode that's do a little mathematical calculation. I think it's 3 plus 5 or something. 2 plus 3 actually. It's 5, and then we store that in the state as with the key foo. Just some testing shenanigans, right? So we are getting this get status message, the local node, the remote node. And I'm actually, where is, I think we had 3 nodes. Remote B. Oh yeah. Remote B is in the game. Yeah, it doesn't matter. First of all, I'm going to blockchain real quick. Blockchain. And I'm going to delete this VM state real quick. This print, we don't care. I'm gonna try to set myself a little bit laid back. Okay. And the mic, of course. I'm thinking because remote B does not tell us that he received the get status message, and I think it's normal because we only connect I'm so sorry. We only connect local node to this guy, and we connect we don't connect to remote node to anyone, but still that shouldn't. Received get status message from. Let's do this again. Okay, this new peer, I'm gonna delete this also because, oh, it's here, new peer. We actually don't care, or we do. But then we do something like and typing goes a little bit better when you don't need to talk. You have no idea how hard it is to type and talk and think at the same time. It's new peer connection. Peer to the server, and I'm gonna say incoming. It's gonna be outgoing. So we say outgoing, right? And then we say the address of the peer. That's something nice to know. It's con. Remote address, I guess. Remote address, yes. Okay, cool. Let's start it again. Make it nice and clean. Okay, now we have new incoming TCP connection, another garbage log, new incoming. And again, I'm typing this in the wrong chat. Incoming, maybe in transport, TCP. You don't get, whoa, what is this? Help. Oh yeah, this function, I remember. Yes. All right. You see, this is already a little bit better, isn't it? Okay, so it's going, we're gonna stop it and we're gonna see what's going on. So we have a remote node. Yes, yes, okay. Then remote gets the status message from, no idea who this is. The local node gets a message. Oh yeah, and remote B gets it. Yeah, it's good. It's all fine. It's all fine. It's working. It was just hard to see, hard to read in this sea of logs. All right. Now we go to the next step. And the next step is basically this process status message. So we ask for a status, we get the status, and then we process the status, right? That's the game plan. Data current height. Yeah. Yeah. Same thing again. Same thing again. S mutex read log. Defer. R unlock, right? Like this. Yes, the message, and then we can return, basically say, wait, we need to get the peer. True, true, true. Peer is going to be S peer map from. Easy. And again, we need to change this thing. Net adder. And maybe we should actually check if the peer exists, to be honest, because something like this, right? And if okay, we could say return fmt error f peer not known, right? We don't know this guy. Who is this guy? Who's this? And actually what we could do is do this and then go back to our previous function. Yeah, and then delete this. So we have basically a better way of handling things. Defer message peer la la la, and then we say peer send message bytes, right? Bytes. We could also say something, receive the get status message. In this case, we're going to say received the status message, and I'm going to make this stand out and make run. That's not working. So everybody received the get status message. I think I know what it is. Is it? Rookie mistakes. Rookie mistakes. Yes, so that's working, right? You see the status. So they received this. Yeah. And of course, you see this error. Here, I'm gonna stop it. Visual Studio, please. Here. So, wait, here. Cannot sync block height to low, right? That's because they all being booted up at the same time. So they all have height 0, height 1, height 2. So they cannot sync with each other. That's exactly what this error is telling us. So how do we fix that? We are going to boot up a late node. A node that is late to the party. So we have our local node, we have a remote node, we have remote node B, and we're going to make a new one. I'm going to make it late node, right? Like this. We're going to also wrap this in and go func like this, this, and this. We're going to time sleep here. How many seconds? We have a block time of 5 seconds. So we need to sleep at least 7 or 8, right? So what we want to simulate is that basically all the other nodes are basically at the same height, 2 of 3. Probably 1 or 2. 2, because 1 is the genesis. So he sleeps for 7 seconds, they all go to 2, he is 1, and he's in trouble, right? And then he can sync. Sleeping 7 seconds, right? Late nodes. Like this, and then, so we need to specify his endpoint, 6000, why not? And then we need to specify a peer list, a list of peers. Yeah, that's perfectly fine. We can do slice of strings. I don't know, let's connect them to 4000. Let's connect them to 4000, why not? And then we're going to start them up. Hoppa. What is this TCP tester? This TCP tester is a simple function that creates a transaction and sends it to one of the nodes to see if this transaction gets distributed. That's TCP tester over TCP, Some relics, some leftover relics from this morning's stream. All right, let me quickly check the health real quick. How do we do this? Not. All right. The next step. Yeah, I think we could boot this and see what's going on. I see something. I see this. Invalid message header 3. Is that RPC? Yes. Buffer. What is poppin'? Very good evening. At least in my place, it's evening. Not sure where you are from. What is poppin'? How is your day? Tell me all about it. We are building blockchains in Golang completely from scratch. And we are basically, this morning we refactored our TCP protocol, and now we are using that TCP network to sync blocks, sending messages, all that good stuff. Gossip. We are gossiping. Yeah, well. Invalid message header. So 3. Why? Let me open up RPC again. Here. What's going on here? Message header 3. Get blocks, right? Of course. That makes a lot of sense, and that is actually a good thing. Because the way we get this error means that we are at a good track. Isn't that amazing? When does an error give you good news? Not all the time, but in this case, it gives us good news. So the problem is we have this message header get blocks, which basically means if we receive this message, we need to get blocks. We need to send blocks. It's 3 as a byte, but we don't handle it, right? So we're going to say somewhere here, case message type get blocks like this. Wait, because now does that mean that we need to give the blocks? Yes, I think so. Oh no. Let me open up server because I'm actually confused. And I will open up this screen so it's a little bit better. RPC the other side. Boom. What's a get blocks message? Let me see what that is, because GD from 2. Okay. Okay. So we're gonna say get blocks. It's going to be new. Get blocks message like this, right? And we're gonna say if r equals hop new decoder, it's gonna be bytes new reader msg data decode get blocks. If the error is not nil, return nil. R. Oh my god. What a function. Yeah. And then we're gonna say decoded message, like the usual stuff. We say from is coming from the RPC, but from. Basically, we're gonna say from who is this message, who sent us this message, so we can keep track of the guy sending us that, so we can respond to his RPC, right? Response, request response. And then, whoops, we're gonna say that the data is going to be, it's an interface, it could be anything, it's gonna be the get blocks, right? I think. Yeah. And we return nil because there is no error. And I think that now we can have something better. So we're sleeping. Yes, so it works. Got get blocks message. So that's step number 3. We are getting there. So we're going to server. received. Got good postman. Got. Aha, here. Okay, cool. Okay, so there is some issue because you see some guy sent, give me the blocks from 0 to 0. That doesn't make any sense. This is the thing, chain height. Ah, yeah. It is. So what we do, what I assume in this protocol is basically we say from, so his height is 0, which is strange because we have a genesis, but we can look at that later on. So he says, give me the blocks from 0 to 0. And if we say that the 2 is 0, we say, give me the whole shebang. That's what it means. So that's good. And I thought I documented this somewhere, if I remember. Buffer. Do you build a database system for blockchain from scratch or what? Sorry, I don't have any knowledge on this domain. Well, to be honest, a database is actually, a blockchain is actually a distributed database, right? So yes, in that sense, we are building a database. But we're actually building a complete blockchain, which is actually, how can I explain this real quick? A blockchain is a distributed database. Distributed, decentralized database. That's what a blockchain is. Try to prove me wrong. Because that's what it is at its core, right? It's distributed, it's decentralized, and we store things. Cryptographically, with some cryptographically swag for people that don't know the space. Are you a Golang engineer or something, Buffer? Or are you a programmer? I mean, it should be because your name is Buffer 0xAA55. So you're definitely not a belly dancer, right? And if so, my apologies. Because you never know these days, you never know. You need to be super careful with what you say. Because anybody can be anything these days. It's crazy. It's crazy. Where is the time? Where is the time? Back in my days, when you clicked select your gender, you had two selections. Two genders, male and female. And if you now click select your gender, you get this list. I don't understand how far the world has come. But I have respect. I respect. You can be whatever you want to be. It's all good. So God gets block message. What we gonna do here? This is going to be very spicy. First of all, add some logging. Decent logging. Received. Get blocks message. Blocks is going to be a slice of core block. Wait, are we going to give blocks or headers? That's the question. Are you a software engineer? Yes. Yes, I am. If the question was to me, yes. So we're going to make a slice of core.block. block. But actually, we could also make a slice of core headers. Yes, I'm a hobby programmer. Mainly I program in C in these days. Nice. That's very, I am so jealous on you, to be honest. If I could program in C, I would do it. Just because it feels very nostalgic. And if you have a good grasp of C or C++, actually C++, throw that language in the garbage can. But if you are good at C, your power is incredible. You will have such a good understanding of how everything works. If you can write C, you can write everything. Literally every single language. But Golang is actually very similar to C. Well, of course we have a garbage collector, I know. But for distributed, to be honest, Golang is basically the best language for distributed applications. Cloud, DevOps, everything that has a lot of concurrency, Golang is the way to go, right? The way to go. But I also write other languages, so no worries. So what are we gonna do? If data from but the problem, I'm not gonna. To be honest, I don't care about. Do not care much about languages. That's true, because software engineering programming is all about solving solutions, right? It doesn't matter what language we use. We just pick the right tool for the right job. I 100% agree. That's the main thing. If you can solve problems, so important. No, but I think you have the, maybe because I'm not professional yet, but you have the right mindset, because a lot of people in the programming community, especially certain programming languages, they are so emotionally attached to their programming language and they know literally everything, right? They know every single thing of their language. They even spend minutes, hours picking the right variable name, the right indentation. Everything needs to be so smooth and so perfect, but they forgot one thing, and that's solving solutions. That's the thing. That's what they can't. They know everything, but they can't solve problems. I'm thinking about this way I'm gonna do this, because how do we have a way to retrieve blocks? That's the question. I think so. Blockchain. Add block, get header, has block, height. We don't get block. I'm gonna cheese a little bit here. I'm gonna do a little cheesy trick. Well, trick is not a trick, it's basically just we don't have a way to get blocks. As a matter of fact, do we store blocks? Not yet. We only store headers. That's a major issue. Because if we only store headers, that means that we cannot process transactions if we sync. And that's basically no good. Could be some kind of a light node. Even then, that's not good, because we need transactions, right? Ay, 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 caramba, caraca, receba. You know what? We're gonna try with headers first, and then we're gonna see. Change of plans. Chains of plans. So I'm gonna make a for loop. I'm gonna say the problem is in the case that 4 is 0, what's going on here? S chain height. Can we do this? I have no clue. We will see. Get header. And that's going to be Y. You win 32, I guess. Like this, right? And then we're going to say it's going to be the header. Error. If there is an error. And if it's not null. Are we going return? Yes, return the error and close this thing. It's over, and then we're going to say headers. It's going to be append headers header. How long it takes to learn Golang? It depends on yourself. That's a very hard question. I don't know what kind of a learner you are. It depends. But you have a gopher in your avatar, so I don't know. You already doing Golang or something, right? How long does it learn? It depends how many hours you put into it. It's a very minimalistic language, to be honest. It's a very, very pragmatic and minimalistic language. So you can learn it instantly. And the best way to learn something is to make a project directly and only learn what you need. That's important. So you pick a project in your mind and you just open up your editor and you start coding. And if you don't know, you want to log users in, you don't know how it is, so look it up. You want to do a database, you don't know how it is, you look it up and you learn and you learn. Because otherwise you will be stuck. If you follow these to-do lists, maybe a to-do list, yeah, why not? But pick something ambitious. Something that can challenge you, right? Because if you go to YouTube and you find a to-do list, right? These tutorials, these guys making these to-do list tutorials, you will learn nothing. You just copy this list and then, yeah, you have a to-do list. What are you going to do? Nothing. What did you learn? Nothing. Make a game or something. Do something crazy. Make a blockchain. But to be honest, I think Golang, you will learn it in a very fast pace. You're going to learn it in a very fast pace, trust me. And why is this append not working? Am I stupid? This result is never used. Maybe... Oh yeah, I see what's going on. So basically, if you do this, right? What the hell is going on? Am I confused? Man. If somebody can spot the issue, I have no clue. I have no clue. I'm totally confused why is doing this. Maybe I looked over something. But what I'm gonna do for sure is basically say something height. Or height is going to be S chain. Height. All right, do we have this blocks message? Actually, I'm gonna print F this and then verbose. Like, man, please, Visual Studio. New line. It's gonna be headers. And maybe I should actually say it's gonna be headers. Vim plugin, not the best. Sometimes it's too slow. Let's see what's going on. You see header, so it gives me a header, right? So why is Golang complaining? Why is the compiler complaining? Now I'm actually, and now it's working. Oh, it's because, I see. Yeah, it's because we don't use it. Yeah, okay, man, please. This is, look at this. The result of append is never used. In this case, I mean, this is never used. Then they should underline this, right? Anyway, confused me. It confused me. All right. And it actually works. So we have one header because, yeah, that's cool. And now we're going to send that header over to or pal or other dude. Do we have this? Or PC. So we have message type block. Why are we not storing blocks? I'm actually disappointed that we're not storing blocks. Maybe we can add it because we can actually not sync, right? So if we don't have blocks, we cannot sync. We cannot do that with headers. No, we can't. So a header, let me open up this real quick. So a blockchain exists out of a block, right? That's why it's called a blockchain, for the people that don't know. But most of the time in these applications, in these blockchains, we split up a block into a header, which basically means the head of the block and the block itself. And the header, so you can see this struct, wait, I'm gonna put it above. So you see this block, right? This is what you actually need to process a complete block. We need the transactions, we need, if it's a validator, we need the signatures, we need the whole shebang. So we can validate and we can process the transaction, which could be arbitrary data, could be smart contracts, could be a currency or something. But we are only getting headers. And the reason why is because sometimes you want information, a compact piece of information. And that's why we're sending headers. So we can keep track of the height. And we don't send the transactions because that could be a lot of communicational overhead in the network, right? That's why we split that up into headers and into full blocks. Yeah, Buffer, so exactly, you asked me, what does a block contain, right? And a block contains a header, transactions, validator, signature, hash. So the transaction is basically a bunch of transactions that are being embedded in the block. The validator is the public key of the node that signed that block, right? That validated and signed it. And then we have the signature. And the signature is used so we can have the public key of the validator. We have the signature of the validator, and then we have the transactions, which is basically, and then we have the hash, excuse me, and then we can verify if that's a valid block, if it's actually signed by the public key that forged the block. That's the validator that forged the block. That's why we have all these things. And a header basically includes some additional metadata, right? So it includes the version. The version is important for protocol decoding and encoding, because right now we have these fields, but it could be in a later point of time we add additional fields, and if nodes did not update their software, it could be that they cannot decode this block. So if that's why this status message is so important, right? So we request the status, and if we see that the node is from version 3 and we are still at version 1, we actually cannot sync, we cannot communicate with that blockchain node because we are out of version. For example, we have the data hash. Data hash is basically the hash of all transactions combined, which should be the Merkle root, basically. And the pref block hash is the hash from the previous block. That's why it's a blockchain, so we can actually keep track of everything that is not being tampered with. And unfortunately, we are only sending headers and no transactions, and that's why we cannot sync. So the question is, what are we doing? Are we quickly adding a block or not? How do we store this real quick? Let me quickly check. Headers, yeah. We could actually do something like real quick. Normally you should persist this in some kind of a database, right? But we don't, we just store it in memory for now. So we could say block. Actually, why are we doing headers then? Buffer. Got it, thanks. You're welcome, man. You're welcome. This Nightbot is going crazy. Sending messages every 15 seconds. Automatically, it's an amazing. 2022. Let me quickly check. All right, so I think we're gonna add these blocks real quick, to be honest, because add block without validation. So we're adding the headers. So actually what we could do is remove the headers and say blocks append BC blocks. Not quite sure if this is going to work, but it could be B. And let's add a headers, right? Because I think we're going to have some backwards compatibility issues. So we're going to delete this because it doesn't make any sense. So we could actually just store the blocks, and then if somebody requests headers, we could just loop through them and only send the headers over the network, right? The question rather is, we need a function BC blockchain get block. I'm going to remove this function here. U132 like this, and then we say it's going to be a block error. Yoink. Actually, let's go. Yoink everything. We already wrote it. Question is, does it work? I think one thing we forgot is basically the genesis. So what is the genesis? The genesis block is the first block of them all. It's a block that's being programmatically coded into the code, into the code, right? Hard coded. Actually, that's a perfect word. The genesis block is a block. Wait, but this cable is doing nasty things with my feet. The genesis block is a hard-coded block that basically describes the initial state of the blockchain. So for example, if I have a blockchain and I'm with my own currency, in my genesis block, I would specify the amount of currency there is available, and the whole rules are basically embedded. Some couple rules, you know what I mean? The initial seed of the database is basically in the genesis block. So that could be a problem. So I'm going to check, where do we add Genesis block? I don't know. Aha. Genesis new blockchain. I think it's in server. Genesis block. I'm gonna search for it actually, not gonna lie. Here. I think we're good, to be honest. I think we're good. So instead of doing this header thing, we do it with blocks, and we're gonna see if it works. Was much easier than I thought. And that's most of the time not a good sign. Where was I? Blocks, right? Blocks. Get block is what we're gonna say. And instead of this header thingy, we do blocks, right? Blocks, block, and of course, we print out the block. And this is going to be a block, right? Yes. All right. Let's go. All right, it gives me a block, but why? Because it's a slice, I see. And now I'm very curious. What I'm going to do is in main, instead of sleeping for 7 seconds, we're going to sleep for 16 seconds. So we have a block time of 5, so it should be at height 3, and I want to see if there are a lot of blocks inside of this slice. That's what I want to test. So we need to sit 15 seconds, do nothing. Can you imagine? Can you imagine? Mm-hmm. Yeah, you see it's working? Yes. So we have 3 blocks, right? Perfect calculations. 5 seconds per block, 15 seconds, 3 blocks. Hey. Like an atomic clock. Like an atomic clock, right? So maybe we could basically deploy this blockchain instead of Solana and Binance chain. Eh? Those guys were offline today. Another big hack. That's the problem, right? The crypto space is full of smart people. Or is the crypto space full of dumb people? I don't know. Should be some of the two. Maybe a both. Maybe a mixture of both, right? Some smart people are out there, man. Be careful with your money. Now we need to send the blocks. That's what we need to do. Send the blocks. So we're going to make, we have message type block, get block status. We're going to say message type blocks 0x6. Oh. Damn, some decoding going on. I'm going to actually copy this, right? So we need to don't write too much. Like this. Paste it in. blocks. We don't have this actually, so we need to make this. Blocks message. We're gonna make that, no worries. Blocks. Blocks. Like this. Now we need to make this. We're gonna do this in a message, like here. I'm gonna say type blocks message is a struct. It's gonna be easy. We're gonna say it's blocks slice of core block, right? Like this. Yeah, the question about this decoding of this slice, I have no clue. But it's gob decoding, so we have a clue. Okay. So now we need the server. Now we need to make sure that if we have a blocks message, you see how I copy paste everything and just adjust. I'm going to say get process blocks message. Speeding up things, eh? Speeding up things. Process get blocks message. So we copy this again, right? Boom. Blocks message. Yeah, like this. We're going to return nil to satisfy the compiler. To satisfy the compiler, yeah. Yeah, well, I think we're gonna do something like I'm gonna print receive blocks. Yeah. Do we need to do something? I think we did everything, right? Let me see if this works. It's 17 seconds. I'm gonna wait because this is gonna take too long all the time. Enable to sync, I think 6 seconds is enough. 6 segundos. Where is it actually? Here. 6 should be good. Wait and see. So 1 block, that's good. Oy. So we don't get the block, right? And I think we don't send it because we are... I think we missed something. Of course. We don't send it. We don't send it. Where's my peer shenanigans? Here. Hop, 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 hop. Actually, copy everything. Huh. Like this. Hop. The message type is blocks, right? Where is my buffer? We need to decode this thing. Copy it again. Should be a byte sprint buffer. bytes.buffer, like this. It's going to be an how did we call this message? Blocks message, yeah? I'm here, man. You see, buffer, I'm using buffers. Can you imagine this? And we have a buffer in the chat. Isn't that amazing? Isn't that amazing? A buffer in the chat. Fully buffed. Bytespin buffer. Amazing. Blocks message. So why is this not working? Yeah, and I know that it doesn't exist. Blocks MSG. And then we say the blocks, and it's capitalized. It's going to be blocks. Basically this big bad boy here. And let's do, actually let's make it clean. Like it's make it clean, like it's never been clean like this. Boom, boom. Maybe a little spacing, right? Do those shenanigans, add it to the blocks, and then we do a bytespin buffer, and then we lock the mutex and all that shenanigans. We do get the peer from our peer map, and we send it. And I think there's gonna be an issue, but maybe not. Let's see. Make run. 6 seconds. Atomic clock. Received blocks. Here. Received blocks. Or late note. The guy who is late to the party received his blocks. Amazing. Thanks to our buffer. Our bytes.buffer fixed it all. All right. So now we need to make sure that now we're going to sync the whole shebang, right? And buffer, don't forget to subscribe to the channel because I need you in further episodes. If you're willing to learn more about Golang, blockchain development, quantitative trading, smart contracts, DeFi, this is the place to be. I also have a Discord community where we hang out, ask questions about videos, streams. Consider that. I would appreciate that a lot. Because I know you're willing to learn. Otherwise, you were not here. Otherwise, you were watching Peaky Blinders or something, you know. But you're here. Okay. Thanks, Buffer. You're the man. I will. Your name. I think. I'm never gonna forget your name. It is what it is. So some people have like these cool names, right? There was a guy called Satoshi Nakamoto. I will never forget this guy. I will never forget him in the chat. Okay, so where is it again? Because I'm getting distracted. Get blocks, where is this? And it's easy because I did this. Okay, cool. What we're gonna do is we're gonna do a simple for loop. So we're gonna say for block Visual Studio in range. Yeah, in range data blocks like this. We're gonna say if r server chain add block like this, and then we're gonna say if the error is not nil, return the error. I think so. Hey, you never know. Let's see. It doesn't look too good. I'm not gonna lie. It doesn't look too good. I was hoping for a miracle. Wait, because there's so much going on. So of course he's telling, the late note is telling that he received a block with height 7 and it's too high. Yeah. That's normal. Okay, we got some blocks, but who is gonna tell us that these blocks are actually blocks? Maybe it's just some garbage that's not being decoded or something. We never know. To know, we're gonna say printf. We're gonna verbose this thing. New line, block. Wait, let's keep that. It's a bit of a trial and error, I know. What the hell? That the hash is empty, I think that's normal. But the validator key and signature, that's because I think block has their own way to decode stuff. Yeah. We could do block with hash. Nah, I don't think it's a good idea, to be honest, to do this. First of all, let us see what the header is actually. Let us see header. Let's do that first. Let's do that first. Version is 1, data hash is 0. This block is garbage. That's clear. So we have an issue with decoding what's being sent over the network. That's for sure. There's nothing in it. RPC. Message. Yeah. This is going to be a nasty one. Because, so the thing is, so take care, I have to go. Buffer, thanks for being here, man. I wish you a very good evening, day, or whatever time zone you are. I don't know. But have a nice one. Thanks for being here. And I see you in one of the next streams, maybe. Who knows, man? I wish you the best of luck in your C programming or whatever you're doing, man. In your endeavors, in any endeavors. Okay, so what the hell is going on? I need to decode this blocks, and I think, so the thing is, blocks is a blocks message. Is this one. But we have a slice to pointer score dot block. And block itself, cheers buddy, and block itself is basically is getting decoded in its own way. So deck.t, what is decode? Right? What is this? Boom. GD doesn't work. Wait, it is. Man, what? Go register elliptic curve. Oh boy, this is gonna be a nasty one. First of all, I'm gonna copy this, to be honest. Yeah. So init is basically each time you call this, the first time you call this package, this file, this whatever you want to name it, it will trigger init. So it will trigger this GOP register elliptic thing. This elliptic P256 is an elliptic curve. It has its own shenanigans inside of it, and we need to tell the decoder encoder, the GOP decoder encoder, how to, that we are going to use that, and it will, I don't know what it does. I don't know what it does under the hood. It's basically registering and blah, blah, blah. It's doing its thing, magic. It's magic. It's literally magic. That's what they're doing. And I don't want to figure it out. Sometimes, let it be. Sometimes code does magic things, and we are engineers. We are not magicians. We don't care. Let it do its thing. As long as it works, it's fine. No, but to be honest, register is basically to register this type to the decoder encoder so it can actually decode encode that thing. So it knows what we are talking about. And probably that's the reason why we didn't see these validator keys and all that, and signature and all that stuff. But still, this header, we need to decode this block one by one, I guess. Or maybe wait. Process get blocks. Yeah. Are we actually I'm gonna do this. A new line, of course, like this, and then I'm gonna say the blocks, the first one. I know it's not the best practice to grab something out of the array directly without checking the length, but I know it will work for testing, just quickly to see. Man, this is getting a little bit complex. I'm not gonna lie. All right, what's going on? Version 1. Something is wrong with these blocks. Something is wrong. All right, let me see. So basically it means that even the blocks we are fetching from our own blockchain are basically corrupt. Right? That's what we see. Why is that? And I get itchy here all the time. I don't know what's going on. Some mosquito sting or something. Back to the roots. Back to the roots. And I'm getting tired, I'm not gonna lie. So my focus is slightly but slowly drifting away. Add block without validation. Blockchain test. Blockchain test. First of all, do or test. Are they still running? That's the question. Make test. Probably not. Of course not. But it's local transport. Local transport. Because we have some tests, believe it or not. But we have a lot of tests. But like this TCP stuff, it's hard to test, right? You can write test at the end, some integration or something, but man. First of all, we make it work by trial and error, and then we add some tests in depth. Because making tests takes a lot of time. Don't underestimate it. Sometimes making a good test, let's say you make one function or one feature, and you make that, and you want to test that, it will most of the time will take you longer than the feature itself if you want to test that in depth. This local transport, this local transport test. You know what we're gonna do with this? Nothing. I'm gonna delete it. Oh shit, what I was doing? Make test actually. All right, that's working. So what we're gonna do real quick, we're gonna write this test on the blockchain, and I think I'm gonna call it a day very soon because I'm getting tired. Like this. Testing.t. I don't know. Let's copy this real quick. Land blocks is gonna be 100,000, whatever. We're gonna add a random block. I'm gonna assert this. We're gonna make a new fetched block. We're gonna say that basically the fetched block needs to be the same thing as the block, I think. All right, so get block is working. That's good. Get blocks, that's fine. But we still have an issue, and I think the issue is going to be in the decoding. It's the GOP encoder is cock blocking us right now, but it's no problem. We're gonna fix that very soon. We're gonna fix that in one of the next streams. But I think we are gonna swap from this blockchain to something else. The next week, we first did our crypto exchange stuff. Beginning of the week, we swapped to our blockchain again, and we're going to mix things up. I'm doing some Solidity stuff, also some DeFi stuff, some quantitative trading stuff, quantitative trading stuff. That's the correct sentence. So if you're willing to learn about blockchain, DeFi, crypto in general, please consider subscribing to my channel. Thanks for watching. If you have any questions, you can join my Discord channel, Discord community I'm trying to build. We are growing each day, where people learning from the videos on my YouTube channel can ask questions and become a better developer, contributing to the code, or learn stuff all together. So thanks for watching. If you have any questions, I see you in the Discord, and I see you in the next video or live stream. Thanks for watching. Bye bye. See ya.